Welcome to Automated Visual Software Analytics. This part is about software metrics. We will have a look into principles of software metrics and a more detailed discussion of software quality metrics, as well as on limitations of software metrics. Let's start with an example. In the illustration here, you see two visualized software metrics, one regarding the nesting level per module and another one the McCabe code complexity metrics, also visualized per module. In both cases, we have software maps that are used to visualize the metric measurements. On the left side, the nesting level denotes the depth of the source code nesting, for example in if statements, whereas on the right side the McCabe code complexity measures the complexity of the control flow by counting the number of paths through a control flow. What we see is that metrics allow us to get an overview of certain aspects of the systems. For example, we can identify a module in the upper left corner that shows a high nesting level, and in the other map we see the same module having a high McCabe code complexity. Most likely this means that during a redesign or refactoring we should have a look on that module, because the metric measurements indicate that these values tend to be too high with respect to the average measures on the rest of the system. This is just one example how software metrics, software quality metrics in this case, can be used to evaluate the current software coding quality or the software process status. Yeah, let's go on. What is the purpose? What is the original purpose of software metrics? Yeah, as it is stated here in the IEEE standard, to make assessments throughout the software life cycle as to whether the software quality requirements are being met. The use of software metrics reduces subjectivity in the assessment and control of software quality by providing a quantitative basis for making decisions about software quality. However, the use of software metrics does not eliminate the need for human judgment in software evaluations. This is a very important point, that even if we can exactly measure certain aspects of software quality, it's still up to the human developer, to responsibles, to experts to interpret these values. The use of metrics within an organizational project is expected to have a beneficial effect by making software quality more visible. Yeah, and in visual software analytics, software metrics are used as a base source of information about software quality. Let's define software metrics in a more formal way. A software metric represents a quantitative measure of a degree to which a software system, component or process possesses a so-called defined property or characteristic, one aspect that is measured. Typically, the measurement techniques are automated, that is, these measures are taken for a whole system within a few minutes or seconds. And the results are measured values, numerical values. For example, the metric lines of code measures the size of a source code unit just by counting the number of lines used to implement a source code unit. Yeah, there's one specific category in software metrics called the software quality metrics. They refer to a software metric that characterizes quality aspects. As already indicated, software metrics are always up to an interpretation. That means the interpretation of measured values of software metrics has a strong empirical basis or character. So we cannot define, for example, a normal value range. Of course, there are some common or usual normal ranges for certain software metric measurements, but there's not an absolute range of normal values in software metrics. Yeah, so far, let's go on. What are general types of software metrics? We can distinguish three general types. One is for the product, for the implementation, for the software system itself, called product metrics. They characterize products, intermediate or final products of the software development. Examples include lines of code, code complexity, or even less sharply defined customer satisfaction. The second category relates to the process. These process metrics characterize methods, techniques, and tools employed in developing, implementing, and maintaining the software systems. For example, the effectiveness of defect removal during development, or the response time of bug fixes processes are typical metrics measured related to the process. There are also a third category of metrics called project metrics. They relate to the project in terms of time, budget, and management. So organizational data about the development process and maybe developer activity. A number of software developers is one indicator. The staffing pattern over the life cycle of the software, or about information about cost, schedule, and productivity. Typically, a metric and a higher level metric relates to several of these categories. So it's not a strict categorization here. The requirements, the general requirements for a given software metric includes the following properties. When we talk about a software metric, we have to ensure that it's simple. Simple means the interpretation should be possible with appropriate effort. It should also be valid. That means measurements should be strongly correlated with the measured property. Stability is another requirement. Measurements should be stable against small changes, maybe small changes in the implementation, small changes in a test case. Another requirement includes timeliness. It should be possible to take these measures within a realistic and short, a reasonable time frame. And analyzability is another requirement. It should be possible to do statistical or mathematical analysis on these measured values. And finally, it should be reproducible. That means measurement should be objective without being impacted by a subjective perspective, maybe a subjective evaluation of a developer or manager. These are general requirements for software metrics, and most software quality metrics fulfill more or less these requirements. They are implemented as algorithms and they typically operate in an automated way. Let's have some examples for different categories of software metrics, in particular for software quality metrics. Regarding the software quality, we can, for example, measure the code complexity. The code complexity can be analyzed by a investigation of the source code. This is done on the implementation, for example, the whole set of modules that constitute an implementation. So it's derived by static source code analysis. Code complexity measures are typically related to and in a way reflect aspects of the coding quality, the coding complexity, and the modularization. Examples include, and this is the most common one, lines of code metric, the nesting level metric, the cyclomatic complexity, also called McCabe complexity, that relates to the control flow complexity, Halstead complexity, coupling and cohesion related to dependencies of modules, code clones, and function points. These are just a few examples of code complexity measures. We will have a detailed look on these software quality metrics in other parts of this course. Now, let's go on to another category of software quality metrics related to dynamics. They are typically analyzed, measured based on recording the system dynamics at runtime, for example, using tracing technology. They relate to and reflect aspects of the system behavior of, for example, function call structures. They are used to find out which modules are actually used when doing a certain use case, when operating on the system. Examples include metrics for code coverage, or bugs per line of code, or feature usage. There's also another category related to organizational issues. These measures are analyzed based on information about the development activities and developers, typically retrieved and derived from, for example, software repositories. They relate and reflect aspects of the system evolution and changes applied to the system over time. Typical examples for those metrics include the number of engineers that have been active in developing a given module, or the number of ex-engineers. Also, the edit frequency is an important measure related to the evolution of a software system, or the depth of master ownership. Yeah, we have seen these three categories and related metrics. Some of them will be subject to individual parts of this course as well. Of course, software metrics are inherently limited. One limitation is that it's difficult to find general normal ranges for measured values of individual software quality metrics. Normal ranges, of course, can be empirically determined for specific software projects, sometimes through rules of thumb. But there is not a clear or objective normal range for certain metric measurements. Another limitation is that measurements can lead to a too simplistic view on the software development reality, so they can cause more harm than good. Measured values suggest precision, but there's a strong tendency for professionals to display over-optimism and overconfidence. The human judgment and software metrics is a difficult relationship. In general, there's another inherent limitation. Developers can adapt their way of working in software development projects if software quality metrics are used in a very strict way by showing a metric-related opportunistic behavior. The simplest example is if you pay developers per lines of code, they will most likely write a large number of lines of code. Yeah, this concludes this part. Let us summarize the key findings about software metrics. Software metrics are essential to quantify aspects of software quality regarding the product, process, and project aspects. Software metrics have an empirical nature, that is, they have to be interpreted for a given software system and within the frame of experience of a developer team. We have also seen there's a large collection of software metrics and related software metric tools that perform software metrics measurements. either as a separate tool or integrated sometimes into a development environment. Most common programming languages are supported by most of the tools, though there's a broad support for almost all common languages, and very precise measurements are possible this way. For software analytics, software metrics represent analysis techniques that deliver valuable indicators about the status of the software system's implementation, its behavior and dynamics, and its software development process and the organizational development as well. So in software analytics, software metrics are key because they give a large number of indicators. They provide data about a large number of aspects of a software system that are typically combined or used as weights for other indications or other data used in software analytics processes. Software analytics tools such as the software map fully automate software metric measurements as part of the overall analytics process. So in a typical software analytics tool, you don't apply individual tools for individual metrics. This is up to the software analytics tool to do this for you and to do it in an automated way. Yeah, let's come to some terminology we have introduced in this part. One key terminology is software metric. It's defined in the IEEE standard as a function whose inputs are software data and whose output is a single numerical value that can be interpreted as a degree to which software possesses a given attribute of a defined property. Software metric measures deliver key performance and quality indicators to software analytics. Another key term was software quality. Software quality is the degree to which software possesses a desired combination of attributes. So as you can see, it's a very weak definition, but in general it's agreed that we have different kinds of software qualities in software engineering. And the software quality metric is defined as a function whose inputs and whose input are software data and whose output is a single numerical value that can be interpreted as a degree to which software possesses a given attribute that affects its quality. So very generic definitions here, but make sure that you understand them and can differentiate between them. As further reading, we can recommend an article called Software Measurement and Software Metrics in Software Quality, appeared 2013, and a book from Stephen Kane, Metrics and Models in Software Quality Engineering. Yeah, finally, some remarks. Software metrics rely on empirical observations and empirical structures. They are not laws of physics. So always keep in mind that software metrics reflect only certain aspects of a software quality. There is not a single ultimate software metric for complex computer-based systems. Each software metric measures only one aspect that can help to determine and interpret aspects of the software quality. Yeah, also in a complex computer-based systems, there are most likely measures of different software metrics outside the normal ranges, the commonly agreed normal ranges for some modules, if there are good reasons. There may be some good reasons due to the nature of a module, due to its development history, due to its status, or due to technical or organizational constraints. For example, if you have a module that shows strange software quality measures, but it's operating and it's almost bug-free, at least for the last 5 or 10 years, then you can ignore these measures. But make sure that you have good reasons when software metric values are outside a typical range. A single software metric does not give too much insights. Combined and monitored over a period of time, then metrics start to be an interesting analytics tool. Different metrics, if we measure them frequently and combine them to higher level metrics, start to provide effective insights. So that's the key difference. A single metric never tells the whole story. If you combine them and if you watch them over a long period of time, then the true value of software metric will appear. Yeah, and this task is core to software analytics.